Hello and welcome to another episode of TimeXtender Tuesdays. My name is Frank and I'm a solution specialist here at TimeXtender. Today we have an awesome topic for you. I mean, all the TimeXtender Tuesdays topics are awesome, but this one I like especially. And that is connecting and using Apache Spark in the Databricks flavor with TimeXtender. Let's jump right into it. Let's imagine we're working at this awesome company called Rainholm Industries. And if you recognize these faces, then you're probably a fan just like me. Obviously, I won't give away the name of the show now, um, and I'll leave it up to you to research. I think the last episode aired in 2013 or something like that. So we have the CEO, Denholm, and we have Jen, who's in middle management. And then we have the two IT guys, Roy, he's a data engineer against Will, but he understood that TimeXtender helps him tremendously delivering the business data to Den and Jen. And then we have his colleague, Moss. He's, like you can maybe infer from the picture already, he's a data science whiz. So let's see where in this picture we will find all the persons from Rainholm Industries. So over here, where we have the use everywhere part, the boss and Jen, they are asking for curated business ready data, which they can consume in their favorite front end tools, Power BI, Tableau, and Click. So they are really interested in curated and well-defined and quality assured data, etc. Roy is doing all the work to really make sure that all the data is connected, that it's up to date, that everything is updated in the data warehouse. And he's also producing the semantic models for the business users to have always the latest and greatest data available. But then there's his colleague Moss as well, and he has his whole own set of ideas, what analysis he wants to do. And he really wants to work not only with the latest and greatest data science tools, but also with the latest data that is available. So he's constantly asking Roy, hey, I need some master data curated in the data warehouse, but I also need access to the data lake where I can find the latest orders, the latest, all of the latest incoming transactional data. And that is on the data lake because once a night or once daily or whatever the frequency is, just doesn't cut it for Moss. And today he wants to make an analysis to present to Jen around order quantities by product groups and by regions as well. And he wants to make that analysis with the latest data. And now let's see how that fits in using his data science tool stack, Apache Spark. So what we will do in our demo, we will connect and read data from the curated MDW data warehouse data, but we will also connect and read data from the raw ODX storage, right? In this case, the data lake. We will join and combine them together, and then we will perform an analysis on the combined data. We will do all of this by using Apache Spark. Let's jump over to the demo. So this is our MDW that I connected to right within the Azure portal. And I can even issue regular select queries in here. And let's go to the MDW schema, which is our valid data. And we will have a look at the customer dimension, which is the master data that Moss is asking for. And we can see that I get the data out here. And we will be also looking at the product dimension, which I can also query in here. But as we said, we also want to access the raw data for Moss. And that is, of course, in our data lake. So let's assume we are talking about the AW2019 data source in here. And of course, if you have worked with the data lake storage of the ODX, you know what it looks like. In here, you have for each table of your data source one folder. And let's have a look at the sales order detail table. And here we can see that this table was at least 2 times fully loaded. So, and we need to identify from the folder name which one is the latest version of the data, right? So all the things that TimeXtender and the ODX for you within the TimeXtender context just does automatically. If you access and use the raw data from the ODX in other tool sets like Apache Spark that are more code-based, you have to build up a lot of logic yourself written in code. So just bear in mind, the tables on the ODX storage have at least 2 versions, and the folder name has a timestamp in it. So that one is from September 14 and the other one is 5 days later, September 19. So later on we will have to determine how can we identify the latest version, and within there here's some metadata, but that is will not be too interesting today. But in the data folder here's Parquet files, and we can even see it was incrementally loaded as well. So we have the full load here, and then we have some kind of increment down here, and everything is stored in Parquet files. So that is what we will need to work with in a second. And now we jumped over to our data science tool stack for today, and that is Apache Spark, and we are using Azure Databricks, which is one flavor of Apache Spark that is super popular among data scientists. And you have to imagine it like a processing engine that is super flexible, but you have to work with it in a very codey way, right? So a lot of the data science tools work primarily with code, and Moss, of course, is a big fan of that. So here we are, and that's his favorite tool set. So in the middle, you can see that we have like code snippets intervened with some explanatory parts. And the first aspect is, and I just want to mention this, we will not cover it today, but I want to mention whenever you're working in such kind of environment, it's really best practice not to have secrets hard-coded, written publicly available into your code, but instead always make sure that you store your secrets, so your passwords and usernames, etc., in a secret and safe place. In this case, I connected up here Azure Key Vault, so I can freely show you all the code that I have because there will be no passwords in it. So this is best practice, and you should consider it in all production environments anyways, but even during development, I would consider it best practice. I have put in here the link where everything is explained, but this is a topic for another episode. So the first step that we need to do is we need to connect to the MDW. And again, here's the link to where you can find all the documentation. But basically, we will be going through a lot of code today, but bear with me, I will try to explain it as clearly as possible. So first, we need to define to what we want to connect. In this case, it's a SQL server, so we need to define the right driver for it. And then we have very typical connection properties like the server name, the server port, the database name. And then we have the SQL user and the SQL password, and this is exactly read from our Azure Key Vault that I mentioned before. And with that, then we create a connection string and we just put in some variables, and the syntax that is required is documented over here. And the way this environment works is you can execute each tiny bit of the code on its own separately, but they will in the end all work together. So let's just execute that one, and that command or these definitions are now sent to our compute cluster. That's what it's called. And it will now execute this code. So basically store these values into these variable names. So, and while we're waiting for this to finish, let's have a look at the next thing that we want to do. So we want to read the customer dimension. We've done it before in SQL, and over here in Apache Spark on the Databricks side, we will use PySpark, so a flavor of Python that communicates with the Spark engine. And basically it says Spark read in the format JDBC, so from a database using the driver and all the variables that we mentioned before. And then in here, we have the option DB table. So which table do we really want to read? And it's the customer table. And you always have to keep in mind, we're talking typically about big data when we're talking about Apache Spark. So the way the engine behaves is super lazy, right? So it does only the bare minimum, and it will only really talk to and connect to and read the data when it's really necessary. So unless we really perform an operation on the data, it will not do anything. So only if we include in our command here the display option to really make it show us the data, only then will the cluster go to the data, connect to the database, and actually do something.
A few moments later.
Now that the previous command is finished, we can execute our read command to get some data from the customer dimension. Let's just execute that. And so it looks a bit different than SQL, obviously, but actually in the end, it will end up sending a SQL command to the SQL Server database, to our MDW in this case, to retrieve the master data, the curated data in our warehouse. And you can see it looks exactly the same like if I had queried the SQL Server, the MDW, directly with SQL. Looks exactly the same. Okay, so that's good. Let's next look at the product dimension and do the same. The command is exactly the same. The one difference is in the DB table option, we put the MDW product table instead of the customer table. Let's execute this cell as well. And you can see here as well, it will just give us the curated data from the MDW, just like you would get it with a regular SQL command. But we also want to look at raw data. And now we need to connect not to the MDW relational database, but we need to connect to the ODX, to our data lake, Azure Data Lake storage. And for that, we need to add a so-called mount point. And the mount point you can think of like a folder on your hard drive, at least in terms of the path that it gives you, so that you know where to access the data. And basically, we will make available the data lake as a local folder, or as something that appears to be a local folder from within our Spark engine here. And so I don't want to go into too much detail, but basically, again, we are reading some stuff from our Azure Key Vault here. And then we are setting some more config options in here and building out our building in our Azure environment here. And again, everything is documented up under this link up here. And with these options set, let's execute this cell and then really make sure that the data lake is available. So we will run this command and the next one as well. And now we can see if we look at the folder that I specified on top, which is /mnt/odxadls, and then we look into our data source AW2019, and then let's have a look at the sales order header table. Then we will see exactly what we have seen while looking directly into the Storage Explorer on the data lake. We can see that we have two versions, one from September 14 and one from September 19, and we have the work folder, which is always used while the ODX saves new data to the data lake. So that is good. That means we are connected and we have all the stuff available. Now we need to figure out, of course, which is the latest version of the data, so that we always really make use of the latest and greatest data. In this case, we of course want to access the version from September 19, but obviously I wouldn't want to hard code this into my program here. So the ODX, of course, does it for you automatically. If you consume with TimeXtender from the ODX to the MDW, it will just automatically give you the latest version of the data. But here within our Apache Spark environment, I have to figure that out myself. So, and for that, again, I can use some code, and basically I use exactly what I used here. I list all the files or the folders, and then I take the max version because it just sorts alphabetically by the timestamp, which ends up in the right order, and we skip the underscore work folder. And if we do that, then we will get exactly what we wanted, the latest version from September 19. So these are the small tricks and small snippets of code that you will need if you do these things manually. And of course, then if you start coding, then you have some best practices. Don't repeat yourself. So you want to encapsulate things in so-called functions so that you can reuse them. And I did that in here, and I called the function get latest ODX version, and that does nothing else but give us back for one particular table the latest version of the data. So now we have that in place. We are connected to the ODX and we know how to find the latest version. So let's then read the sales order header. And in this case, we use again spark.read, but not spark.read with the JDBC connection, but we will read spark.read Parquet because we want to read Parquet files from our ODX ADLS, from the AW 2019 data source, from the sales order header table, and we apply to that folder the function that we defined before to get the latest version. Now let's check out what that looks like when we execute that. And this will take a bit longer than just getting data from a relational database, typically, because in this case, the engine does do a lot of the work itself instead of just sending out a SQL statement over to the SQL server, and SQL Server does the heavy lifting. In this case, the Spark engine does the heavy lifting. But now that we have the data back, you can see that it looks also pretty much similar to what you would get back from the MDW than what we have seen on top. So now we have our sales order headers read right from the data lake, from the latest version of the data, even including all of the increments. So that worked pretty well. Let's do the same thing for the sales order detail table. Again, we just apply our function, read from Parquet files, and then we just point it to the sales order detail folder. Let's run that. And also it works pretty well to get the data back. Obviously the data sets here are pretty small, but I think the idea is pretty clear. So now we have in memory raw data from the ODX, and we have curated data from the MDW, and we have them both connected and ready to use. So let's create a data set for analysis because we want to bring them together. The third step is to join them together. And the code is also available on GitHub for you to share. The link is down in the video description. But the important part is basically you do the same things here like you would do in SQL, you just do it in another syntax. So we start with the sales order details or our fact table, and we join to it the sales order header based on these fields, and we join the customer dimension onto it based on the customer ID, and we join the product dimension to it based on the product ID. From this new very wide data set, we just select certain amounts of columns. Not all of them are relevant for us. And we even can add new additional columns that we will need in our analysis here. So we create a new descriptive column, region, territory, where we combine country, region code, and territory name. And we do category, subcategory. We also add a new column for that. And we can even calculate new measures this way. With column, and then we calculate the gross line total. We multiply the order quantity with the unit price. And again, we will display the result, and all of this goes like in one big processing step. Let's check this out. So now we can see the subset of the columns from the joined tables, and we can see the order quantity, the unit price. So this was available before, territory name. So this was all in place before. Now here comes the new columns, region, territory, and Also the new column category subcategory and the gross line total that we just calculated. So that works all pretty well. You can also make it available as a table that can again be queried in a SQL-like manner, and it will even be available here in this data section. If we look here under tables, you can see my analysis is down here available, and this will now be, if I click on it, show us the exact same data set. It's just persisted within this workspace here. But let's jump back to our notebook and complete the analysis that Moss wants to provide to Jen. And now we can really do some actual analysis in here. You can even use the cell output in here, and you can have it available as a pivot table or something, even highlighting the distribution of the data between the products and categories and the regions with all the highlights of what was sold where, in which quantities, what's the minimum, what's the maximum. But you can also do more advanced stuff again in code. And for this, I copied some snippets that I found also on the documentation and made some adjustments. But basically, this is a way to programmatically create some nice charts. And let's also run this code. And I will give Moss all the things that he wants to show to Jen, combining again curated data from the MDW and raw data from the ODX. And now we have, for example, scatter plots of the gross line total versus the order count across, in this case, the categories. But we can, of course, also use our newly created fields category subcategory in here and just switch up the analysis in this visualization. Let's just wait for a second, and now we can see that it has all changed. The gross line total versus the order count, so how big are the orders basically across the different product lines, and that's what we see in here. So with that example, I hope we could give you an idea of how you can use and leverage all the things that you can build in a blazing fast time with TimeXtender, connecting to data, getting the raw data to the data lake, getting curated data in the data warehouse, providing all the business value to your business users to make them happy, but also give the data scientists the access and the data that they need to perform the advanced analysis that they want to do based on curated data from the modern data warehouse, but also by accessing the raw data on the ODX to bring together the best of both worlds. Give us a thumbs up if you liked this topic and let us know which other data science tools you would like us to have a look at. You will find all the links that were mentioned in the video down in the video description. And come join us in the TimeXtender community at support.timextender.com. Ask all your questions, meet awesome colleagues, and we will talk to you in the next episodes.